Hi, everybody. It's Professor Mitchell. We're continuing with Chapter 3, and today we're talking about Section 3.5, which is measures of relative position. So measures of relative position compare the position of one value in relation to other values in the data set. So we're going to be talking about two different kinds of measures of relative position. There are percentiles, and then there are quartiles, which are just a specific type of percentile. So percentiles measure the approximate percentage of values in the data set that are below the value of interest. And I'll give you an example. I think this was the first time that percentiles ever made it onto my radar. When I was in school a few years ago, we used to take these standardized tests, and I don't know, a couple months after we took the test, our parents would get a report in the mail, and it would say something like, on reading, your child scored in the 85th percentile. And what that means is that 85% of the kids who took the test did, how should I say this? 85% of kids who took the test did not as well as you did, okay? And 15% did better. That's roughly what it means, okay? So I always feel like sticking a specific number in there will help it make more sense than when I say something like the pth percentile of a data set, where p is any number between 1 and 100, is the value that at least p% of the observations will fall below. So if you stick an 85 in there, the 85th percentile would be the value that at least 85% of the observations will fall below. And you see some other examples here. 20% of data values are below the 20th percentile. 73% of data values are below the 73rd percentile. So here's how you find percentiles manually, which is the way that we will be doing it. First, sort the data from lowest to highest. Next, you have to calculate an index point. Now, this index point is basically a position number where your percentile is going to fall. And the way that you calculate that index point is to take basically p% of n, where n is the number of data values. Now, we'll talk about these next two lines here in a second. Notice that this index point is not the value of the percentile, all right? So the index point tells you where to look for the percentile. Now, there are two different things you have to do depending on whether this index point I comes out to a whole number or not. If it doesn't come out to a whole number, then you round it up to the next whole number, and that's a very important point. I don't think I have ever done this before. You don't round the way that you normally round, always automatically round up. Okay, so let me get this situated again. There we go. All right, so again, if that index is not a whole number, you round it up to the next higher whole number. But if it is a whole number, then you take the midpoint between that position and the next position. So for example, if I came out to 20, then the 20th percentile would be the mean of the 20th and the 21st numbers on the list, okay? If I said 20th percentile just then, I didn't mean to. If I came out to 20, all right, that's totally different than saying 20th percentile. Sorry about that. All right, so here's an example. Miles per gallon are recorded for a sample of 12 cars, and the ranked values are shown below. So these are already sorted in order, and they want to know what is the value of the 60th percentile. So the first step is to find 60% of 12, which is 7.2. Because 7.2 is not a whole number, we're going to round it up. See, this time they said up to get to 8. So to find the 60th percentile, that would be in the 8th position. So the 60th percentile is 31.1 miles per gallon. And what that means essentially is that 60% of the cars in this sample have fuel economy less than 31.1 miles per gallon. I guess technically I should say less than or equal to. All right. Definition gets a little technical. Okay, now I want to caution you very strongly, all right? Different books have different ways of calculating percentiles, and unfortunately, sometimes they give different answers, and that goes for Excel, all right? So I don't know exactly what formula Excel uses to calculate their percentiles, but you see this note here. Excel uses a slightly different technique to calculate percentiles. So Excel output may be different than if you calculate manually. And I'm going to guess that if you're doing online homework, they're probably going to be looking for the answer that would be found if you did it manually. If you're doing this in your real life, then it really doesn't matter all that much. You know, if there are a group of you in the office that are calculating percentiles, I would just say make sure you're all doing it the same way. You know, and so my suggestion would be if you're doing it in real life, just use Excel because that's easier. Okay, but you do need to know that Excel may give you a different answer than what you would get if you did it manually. Okay, so here is the name of the formula. It's percentile.exc. Array is where you put the range of cells that your data are in. So for example, A1 colon A20. And then K is the percentile number that you want, like 60. I'm sorry, I take that back. K is the percentile of interest between 0 and 1. So if you wanted the 60th percentile, you would put 0.6. Okay. All right, so this is sort of the reverse of what I just described. The percentile rank identifies the percentile of a particular value within a set of data. So let's say that I gave a class an exam, and I wanted to know what is the percentile of a score of 70 on the exam. So I would hope that that percentile rank is pretty low. Meaning that not too many students scored lower than that. That would be my hope. So the way that you find that is by using this formula. The percentile rank is the number of values below the number you're looking at. So in my example, the number of students who scored below a 70 plus 0.5 divided by the total number of values, and then multiply that by 100. Okay, so in this example, what is the percentile rank for the car with 60, I'm sorry, where am I getting 60? 35.8 miles per gallon. All right, so I count, there are 9 cars that have fuel economy less than that. So I take 9 plus 0.5 and divide that by 12. And I actually checked on my calculator. This comes out to be about 79.166666. Percentile ranks are rounded to the nearest whole number, all right? I can't remember ever hearing anybody talk about percentiles that are decimals. They're always written as whole numbers. So in this case, you just round it to the nearest whole number. All right, that brings us to quartiles. Quartiles split the rank data into 4 equal groups. The first quartile, Q1, is the value that constitutes the 25th percentile. So just remember the first quartile equals P25, the 25th percentile. The second quartile, Q2, is the value that constitutes the 50th percentile. Note that the second quartile is the same thing as the median. So in my experience, you don't really hear as much talk about Q2. People will often just call that the median. And then the third quartile, Q3, is the value that constitutes the 75th percentile. So this would be the number, the value, that 75% of the values in the set are less than that number. All right, so here's an example. If our sample data consists of these numbers ranging from 11 to 25, notice there are 11 of them. Q1 is the 25th percentile. So the first step is to find the index number for n equals 11, p equals 25, which is 25% of 11. 25% of 11 comes out to 2.75. So we'll round that up to 3. And Q1 would be equal to 13 because that's the third number on the list. All right. Quartiles can be found in Excel using the quartile.exe command, very similar to the percentile.exe. So first you put in your array, the range of cells where your data is located, and then you put a number either 1, 2, or 3, depending on whether you want the first, second, or third quartile. And I think I had better put the same cautionary note on this. May give you a different answer than if you do it manually. All right, so I would just exercise caution if you're going to use Excel in this class. All right, now the interquartile range is not a measure of position. It is actually a measure of variation. And what we're going to use this for in a little bit is for detecting outliers. The interquartile range, IQR, describes the middle 50% of a range. So to find the IQR, you subtract the first quartile from the third quartile. So IQR is equal to Q3 minus Q1. So again, what this tells you is what is the range of the middle 50% of your data. All right, so you're going to see IQR come up here in a little bit when we use it to detect outliers for making box and whisker plots. So what a box and whisker plot is, it's a graphical display showing the relative position of the 3 quartiles as a box on a number line. And it also shows the minimum and maximum values in the data set as well as any outliers. So here is a sample. Outliers are indicated with stars. All right. This thing here is called a whisker. This line goes from your lowest value that is not an outlier up to your first quartile. And then you draw this box. The box goes from the first quartile to the third quartile, and it has a line drawn inside at the median. And then finally, you draw another whisker that goes from the third quartile up to the highest value that is not an outlier. And if you had any high outliers, they would be indicated out here with stars. I would say most of the time, you're not going to have any outliers. All right, that's been my experience. Okay. All right, so here's IQR again. This is how we're going to detect outliers. So the formulas for the upper and lower limits of outliers, the upper limit is found by taking the third quartile and adding 1.5 times IQR. Remember, that's the interquartile range. The lower limit is found by taking Q1 and subtracting 1.5 times IQR. So any values that are beyond those limits, all right, anything that's lower than the lower limit or higher than the upper limit is considered an outlier. So if we had any of those, they would be indicated with stars on the box and whisker plot. All right, so here's how you construct a box and whisker plot. First, determine the 3 quartiles. Then draw a horizontal number line that spans the length of the data values. I was just doing one of these earlier for one of my other classes. Next, draw a box above the number line extending from Q1 to Q3 with a center line at the median, also known as Q2. Then your whiskers extend from the central box to the highest and lowest values that are not outliers. So before you draw your whiskers, you would better figure out whether or not you have any outliers. And if you do have outliers, then you're going to plot those with an asterisk above the number line. So in this example, it looks like our data ranges from about maybe 0.6 up to about 4.5. It looks like Q1 is about 1, Q3 is about 3, and I'd say the median is about 2.5. It looks like the highest value that is not an outlier would be that 4.5, and then you have this very unusually high score at 9. Okay, so that's indicated with a star. All right, so here's an example. This table shows the number of visitors to national parks in millions. Notice there are 15 national parks listed, and they are already sorted in order from highest to lowest. So the first thing we're going to do is find our quartiles. So the index point for the first quartile would be 25% of 15, which is 3.75. Since that's not a whole number, we'll round it up to 4. So the fourth number, starting from the smallest number on the list, would be 1, 2, 3, 4. That would be the 2.37. So the first quartile is 2.37. I'm going to ask you right now to pause the video and calculate Q2 and Q3 and just make sure that what you get agrees with what they got because they did not show all their work for that. Okay, but you do it similarly to how we did it here. So pause the video and try that. Make sure you can get that to work. All right, so now we'll move on. The interquartile range is Q3 minus Q1, which is 4.26 minus 2.37, 1.89. So the upper and lower limits for outliers, the upper limit would be Q3 plus 1.5 times IQR. That comes out to 7.095. The lower limit, Q1 minus 1.5 IQR, comes out to negative 0.465. So clearly there are not any low outliers because you can't have a negative number of park visitors. However, what this is saying is that any park that got more than 7.095 million visitors would be an outlier. So that would be the Great Smoky Mountains Park with 11.31 million. All right, and notice that the largest value that is not an outlier is the second highest value, which is the 5.97. So my whisker on the right is going to stop at 5.97. So let's have a look at that. Here we go. So the left whisker starts at 0.59, goes up to Q1, which is 2.37. The box goes from 2.37 to 4.26. It has a line at 3.27. And then the right whisker goes up to 5.97. Oh my goodness, they put that in the wrong place, didn't they? That should have stopped. That should have stopped here. Okay. Well, I don't really know how to fix that for them because I don't think I can edit their picture. So I guess what I will do is just try to kind of scribble this out. That should not be there. Sorry about that. And then, what do you think? Should we make this arrow go like this? All right. Okay. I don't know what happened there, but clearly that is not correct. Okay. All right, but this other thing looks okay. The star at 11.31, that's where we have our outlier. And I believe that's going to do it for section 3.5. So we will see you next time. Only one section to go in chapter 3.